This is Dr. Sridharan from SNS College of Technology. In this sessions, we are going to discuss about flame photometry and their applications. Introduction about the flame photometry. Flame photometry is a type of atomic emission spectroscopy and also known as flame emission spectroscopy. The flame photometer is an instrument used in inorganic chemicals analysis to determine the concentration of certain metal ions. Especially, we are analyze the alkaline earth metals and alkali metals like sodium, potassium, lithium, and calcium. That means group 1 alkali metals and group 2, that means alkaline earth metals, are quite sensitive to flame photometry due to their low excitation energies. Principle of flame photometry: it is a controlled flame test with the intensity of the flame color quantified by photoelectric circuitry. The intensity of the color will depend on the energy that had been absorbed by the atoms that was sufficient to vaporize them. So we can use it for the different metals. It creates the different colors. That means change the intensity. So that is a very essential part to determine the various alkaline metals and alkaline earth metals. The sample is introduced to the flame at a constant rate. Filters selected which colors the photometer detects and exclude the influence of the other ions. Before use, the device requires calibrations with a series of standard solutions of the ion to be tested. So both previous one we discussed about the atomic absorption spectroscopy, and here also we can use it for the standard solution. So we are make it for the different known concentration of the solution, and we go for then we go for the sample, the given sample of from metal ions, different elements or substances. We can go for the analysis. So the preliminary steps, we are preparing the standard solutions. That means known concentration of the sample concentration. The flame photometry is expensive compared to the flame emission spectroscopy, where the emitted light is analyzed with a monochromator. Its status is similar to that of the colorimeter compared to the spectrophotometer. It also has the range of metals that could be analyzed, and the limit of detections are also considered. Working principle of flame photometer. The working principle of flame photometer involves several essential steps. They are similar to the AAS, atomic absorption spectroscopy. Sample introduction. Sample solution is introduced into the flame through the atomizer. The solution is typically aspirated or nebulized, ensuring a fine spray for the efficient atomization. And next step, the atomizations and desalvation. The sample enters the flame, the solvent evaporates, leaving behind the dissolved elements in the form of atoms ions. The high temperature of the flame further excited these atoms or ions. Then emission of light. The excited atoms or ions in the flame emit light at specific wavelengths, characteristics of the element present in the sample. And we use it for the different filters. That means monochromator as selects the desired wavelength of light emitted by the sample, while blacking out other unwanted wavelengths. So that means the wavelength selection by using the monochromators. Then the very common steps for all spectroscopy technique, detections and measurements. The detector captures and selected wavelength of the light and converts into an electrical signal. A signal processor then measures the intensity of the signal, which is proportional to the concentration of the element in the sample. Next we go for the analysis of the sample. The measured signal is compared to the calibration curves or standards to determine the concentration of the elements in the sample solution. So this allows the quantitative analysis of the specific element of the interest. This shows the flame photometry instrument. This is a schematic diagram of instrumentations. Here we are start with the sample solution that is spray out by the nebulizers. We convert to the flame and followed with the lens, monochromator, detector and then display. The basic components of a flame photometer: flame source, that means getting from our sample solution, heat to excite the atoms or ions in the sample. It is typically a propane or natural gas flame. Atomizer, then monochromator, the selection of the particular wavelength, it allow it for the detector, and signal processors. So similar to EAS, here also the monochromator, detector and signal processor will come for the all spectroscopy techniques. Applications of this technique: this flame photometry, clinical chemistry, environmental analysis, pharmaceutical analysis, food and beverage industry, and geological studies. Thank you.